Okay, hi everyone. So today again we're working on graphing inequalities. Graphing line inequalities. Oops. Line inequalities, yes. So let's do some review about what inequalities are and why do we use them, and then we'll apply that to graphing lines. Now, line inequalities, or inequalities in general, were a big step up when it came to the use of algebra. In the real world, are things ever that strict? The example is when you tell your friend, I'll be home after 3. Okay? You never tell your friend, I'll be home exactly at 3 and only at 3, and don't call me any other time except exactly at 3. I need you to call me at 3. Like, example is x equals to 3 is great because the answer is, hey, 3. But in the real world, answers are not just one value. Answers are not just one value. They are a range of values. And that's why we have inequalities. For instance, if I say x is greater than or equal to 3, that means you can call me at 3 or after 3. I'll be home. Sure. And that's the cool thing about inequalities, is that they give me more than one answer. It's actually, remember, a range of answers. So where x could only be 3, right, on the number line, let me just graph this as 0 and this as 3. Only one answer. This answer here could be a range of answers that are 3 or greater. And we draw an arrow there to say, hey, 3, 4, and 5, all these answers are totally okay. Like, some of you guys turn off your phone so no one can contact you after 10. So call me before 10. Because at 10, I'm going to sleep. But for me, it's more like 2 o'clock in the morning. So inequalities allow me to say there's more than one answer. And you know what? That's life. Honestly, in the real world, that's life. There's more than one possibility. So maybe if we were graphing, let's use this example. If I say y, so now let's look at easy, basic line graphs. If I say y is greater, let's use this one first. Y is equal to 3. Okay, y is equal to 3. So if I ask you to graph y is equal to 3, you can look at this as y equals to mx plus b, where there is no x here, right? There is no x. So this is y is equal to 0x plus 3, and that means my slope is 0. Just a way of looking at this. So would this be a horizontal graph or a vertical graph? Okay, ask yourself this. If I see y is 3, do I care about what x is? Y is 3. 1, 2, 3. Y is 3. Here's 3, guys. And then my line graph would look like this right here. Let me use a different color. Y would be 3. And we talked about horizontal and vertical graphs, as I try to remind you guys. If y is 3, I don't care about what x is. So y is always 3. I live on the 3rd floor. I live on all the 3rd floor, apparently. Now, how would this graph look like if this was in itself an equality, if I change this up? If I said y is greater than or equal to 3. Y is greater than or equal to 3. Well, we would graph it very similarly. 1, 2, 3. Remember we said y is greater than or equal to 3. Here's 3. We're going to graph our line like we typically did before. Here is 3. And here's the cool part. Y doesn't only have to be 3. It could be 4, 5, or 6. And the way we denote that is by drawing or shading the area that's okay. And in this case, take a look. We're okay to be anything above 3. Hey, 4 is okay, 5 is okay, 6 is okay. All these values are going to be okay. And we can verify that. If I said y was 4, hey, is 4 greater than or equal to 3? Well, yes, it is. Is 5 greater than or equal to 3? Well, yes, it is. Right? If y was 4, y was 5, would this be a true statement still? Yeah. So instead of being right on the line, our answer is now a total region of answers. Can you remember as a child, your parents would say, hey, you can play any place on our side of the street, but don't you dare cross the street? Your parents drew pretty much a inequality line for you. You have to be on our side, less than this street, or you can be greater than that street, or less than our street, okay? You do this at your house, maybe with if you have little brothers or sisters. If you're a sibling, you said, "This is my side of the room. That's your side of the room. Don't cross my side of the room. Don't you dare touch that line." Now, when it comes to inequalities, remember we had two types of inequalities. We had our equal to or not equal to. So the example is, let me draw this another line. X, let's say x is greater than 3, and x is greater than or equal to 3. So if you remember, this is not included. Whoops, included. That means we weren't allowed to include 3 in this, and this was included. And how was that represented in our line graph? This was a dotted or hollow, and this was a solid. Now, if I'm graphing these as line graphs in 2 dimensions, not just 1 dimension, will this be a vertical graph or a horizontal graph? Will this be vertical or horizontal? When x is 3, 1, 2, 3, here's 3. X is 1, 2, 3, here's 3. This was going to be a vertical graph because all I care is that x is 3. But we can't do a bunch of circles here like we did in a line graph. We're going to use instead a dotted line, dot, 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 to denote, don't you dare touch 3. While on the right side here, since we could be equal to 3, remember how this is our equal sign? We're going to draw a solid line at 3. So first, make sure you take note of this, that the difference between an equal or not equal to, right? On the left side, we have x must be greater than 3. Don't you dare touch 3, because 3 is not included. In English, we might say, hey, call me after 3. And if you try calling them at 3, they're not home yet. Maybe they're just walking through the door. Or sometimes you might say, I'll be home at 3 and onward. So I'll be home at 3 and onward. Sometimes your parents use this when it came to you playing video games. You can play after 3. Hey, Mom, it's 3. Nope, I said after. Wait just a little bit longer. Or they'll say you can play from 3 onward. Okay, from 3 and onward. So let's look at the shading. X is greater than 3. So give me a number that's greater than 3. In your mind, think of a number that's greater than 3. So a number greater than 3 would be maybe 4, 5, or 6. So isn't 4, 5, and 6 all on the right side here? So all these values are allowed. Now, you might notice that I'm changing the way I'm shading. The way you shade, it doesn't matter. Some people really like doing this. They like to make sure every nook and cranny is totally covered. And know what? That's too much work. What happens is, what's the difference between you seeing this and me like super shading it? It gets the same message across, right? So just spend less work. What if, Mr. Ko, if I just do a couple of lines like that? 100% okay. 100% okay. As long as you understand that I'm covering everything in this region. Okay. What if I draw a bunch of vertical lines instead? Sure, you could do that. That's fine. As long as you understand I'm covering everything in that region. Right. So on the right side, let's look here. X is greater than or equal to 3. So solid or dotted? Well, I'm allowed to be on 3. So that's why we're going to use a solid line here. And we're going to go ahead and shade that to the right. Another way of looking at this is, I mean, you don't have to do this, but we're saying all the answers on the right side forever are true. Okay, and just like when you zoom in on a map, you guys ever zoom in on Google Maps, does it mean the rest of the world disappears? No, the rest of the world is still there. We just didn't want to graph it because we're too lazy. Or it doesn't matter, right? We're just graphing the part that we decide to graph, right? It's our own little graph here. Okay, so we want to take away 2 things right now. If this is not equal to, we have to use what we call a dotted line, because you're not allowed to touch it. It's almost like an invisible force field, versus an equal sign here where it has to be solid so everyone can see that that's included. Okay, the 2 big takeaways. Now, So let's go ahead and graph a regular line that we've seen before. Y is equal to, let's say, 3x plus 2. Okay, let's graph this first. So we're going to graph this 3 times in a couple different ways. Say this is 1, 2, put a dot. How do I know that? Because y equals to mx plus b. B is my y-intercept, and m is my slope. So remember, b is our first value we always put a dot down for. If x was 0, y would be 2. So that's why if x was 0, y would be 2. That's my 2 value, x's and y's. Now the slope says it's going to be 3, m is equal to 3, b is equal to 2, and it's really 3 over 1 for us to think of it as a slope, a rise over a run. So we're going to rise 1, 2, 3, and over 2. Oh, sorry, over 1, I'm sorry, over 1. So this is going to be my regular line. So what does this line mean? This is just all the valid points that would make this equation true. This is a graphical representation of this equation. Let me walk down. If I go down negative 1, 2, 3, and back 1, we're looking at negative 1, negative 1. Okay, again, back down 1, 2, 3, and then back 1. That looks like negative 1, negative 1. Is this a valid point in my graph? If y was negative 1 and x was negative 1, oops, sorry, let me write the 3 there. Is this equal sign going to be true? Is the right side going to equal to the left? Negative 1 is equal to negative 3 plus 2. And yes, negative 1 is equal to negative 1. That is a true statement. Point negative 1 is on the graph. And also all these decimals along the way. Okay, so now let's change this to inequality. And say, you know what? I don't want to get stuck on the line. I want to be better than that line. So if I say y is greater than or equal to 3x plus 2, what really has changed? Has the slope changed? Has the y-intercept changed? No. Actually, this is almost fundamentally all the same steps as we've been working on for the last 3 weeks. We're just adding inequalities to it. We're just making this a different type of graph, a little more detailed graph, but all the same characteristics still. The y-intercept is still 2, put a dot. The slope is still 3 over 1, 1, 2, 3 over 1. We're still going to draw a line. Now be careful, is this a dotted or solid line? This is going to be solid because of the equal sign, right? It's greater than or equal to. That means you could be equal to this line. I'm going to draw a solid line here. If you look at these lines, these are all both parallel, right? Because they have the same slope. Now, I want to say one more thing here. My question to you is, if y is greater than the line, y is greater than the line. Let me write that. Y is greater than the line, right? If y is greater than the line, would I shade above here or below here? Above or below? Above or below? And I want you guys to do this very simple skill. This is like the easiest skill in the world. So please don't shun this off. Can you guys all put your finger or put your pencil on your line? See, put your pencil on the line. Look what I did. I just put a little piece of red there, okay? All right? This is how easy it's going to be. So please don't not believe this. Okay? Everyone, put your pencil on the line. And then ask yourself, y is greater than, right? Y is greater than the line. We're on the big side. See how this is the big side? Which way would you try to go? Would you go up or down? Would you go up or would you go down if you're trying to say greater than? You would go up. Thank you. So up, up, up. That means we are greater than the line. All these y values that are greater than the line, these are cool values. These are excellent values. These are perfect values for me. So we would shade up. If you don't like the way this looks up, you could shade across this way, fine. If you don't like that shade, you could shade across this way, no problem. But the idea is we're trying to show everyone that any region up here, we're cool. That's my side of the room. So y is greater than that line. Let's show the contrast. Let's do the other way. Y is less than, here's my ink. Y is less than or equal to 3x plus 2. Okay, y is less than or equal to 3x plus 2. My y-intercept is still 2. My slope is still 3 over 1. 1, 2, 3 over 1. Remember, my slope is 3. My y-intercept, my b-value is 2. So is this solid or dotted? Look at this here. Is this solid or dotted? Y is less than or equal to. So being equal to means I can definitely stand on that line. Hey, look, they're all parallel lines, right? They're all parallel lines. Now, we're not just equal to the line anymore, right? We're not just equal to the line. Y is less than. So again, here is the dumb trick. Please don't shake it off, okay? If you put your pencil on the graph, when I say y is less than, remember y goes up and down, right? This is y. Y is less than the line. Y is less than the line. Y is less than. All these values down here are less than the line. And that's the way we would shade. Y is less than the line. Now, what does this mean, okay, when we say y is less than? So when we're saying y is greater than, y is less than, it means that we don't only have one answer now. We don't just have answers that are on the line, but anything in this region would be okay. Now, let me go ahead and draw this one more time. Let me give us some space, and I'm going to give you guys some examples here to work with. Y is greater than 3x plus 2, okay? So I'm going to ask you, are these points okay for you? Like example, let's say you tell your friend, call me after 3. And then he says, can I call you at 4? I'm like, yeah, that's after 3. How about, can I call you at 5? Yeah, that's after. Can I call you at 6? Yes, that's after 3. Can I call you at 3:15? Yes, that's after 3. Can you stop asking me questions now? And that's what we're going to do. We're going to, unfortunately, be that friend. So my question now is, given this, okay, check if let's use something easier. 0, 5 is okay. Okay? Is 0, 5 going to give me a true statement here? So how do we do this? We're just going to go ahead and plug it in. We're going to say, if I plug in 0 and I plug in 5, right? This is an x and y value. Let's rewrite it. Is 5 greater than or equal to 3 times 0 plus 2? How did I do that? Well, remember, x here is going to be 0 and y here is going to be 5. So we're just replacing our variables in. Then just do the math. 5 is greater than or equal to 3 times 0 is 0. Is 5 greater than 2? Yes. Now, look on this graph here. 0, 1, 2, 3, 4, 5. Look here. That's 0, 5. Isn't this in this shaded region? Yeah. That point is in the shaded region. That means it's going to be okay with me. It's a true statement. What about, let's check another one. Let's check some other ones. Is -2, 6 going to be okay? -2, -1, -2, 6. That's way up here, right? Way up here. When does -2, 6 look like it's in that shaded area? -2, 6. Does that look like it's in the midst of being shaded? It looks like it to me. But let's verify this mathematically. Is 6 greater than or equal to it's 3 first, right? 3 times -2. Let's check if this is true. Is 6 greater than -6 plus 2? Well, that's greater than, oops, come on. 6 is greater than or equal to negative 4. This is 100% true, right? That's a true statement. Is, though, that I'm going to pick a point that is for sure not. I'm going to pick 2, 1. Everyone see how 2, 1 is obviously not? 2, 1 is not in my shaded region, is it? So we're going to check 2, 1. Y, x and y. 1 is 1 greater than 3 times 2 plus 2? Does that even look like it's true? 1 is greater than 6 plus 2 is 8. Is 1 greater than 8? Does that make any sense to you? Is 1 greater than 8? No, this is false. Not true. So what happens is points that are not in the shaded region make the equation a false statement, right? It's not true. You're just wasting time here. And know what? This is kind of life. Like, we make decisions this way. You say, hey, are you free on Saturday? Well, what do you mean? What time? And then you make a graph in your brain, right? You say, okay, I'm free after 10. I'm not free. I'm not free before 10. You're making decisions like this always automatically. When you guys get older, you make financial decisions this way. You say, do I have enough money to go on a vacation to Hawaii? And it's not just about money, it's about time. Depending on the time, have I saved up enough money yet? Or maybe it might be more expensive in some seasons than others. Maybe you have to include, am I going to bring my wife or not, right? Okay, so all these other decisions that come into play, where it's not just a simple line equation, it is a whole realm of possibilities. Your mom might have said, for instance, you say, Mom, I want a Nintendo Switch, or I want a new gaming PC for Christmas. Your mom's thinking in your brain, hey, by December, will I have enough money? Or maybe I'll have enough money in January. Or maybe it's all about how much money do you want to spend. If it's a little bit, hey, we can afford it. But if it's a lot, or if it's the other way around, right? We can't afford it. Over here, like, we can't afford it, or we can't afford it. Or maybe it's about you. I want the 20. I want a 1650 graphics card, NVIDIA 1650. Oh man, that's not enough power. That's not enough power to power what I want. I need the new 3060 graphics card. If you guys have any clue what I'm talking about. Or maybe it might be a PS4 or PS5, right? Oh, that game's not supported. It has to be over. Now, in the real world, inequalities is actually how we think of many of our answers. It's not just one answer, it's a realm of answers. And why this is why it's kind of important. Now let's graph this 2 more times very quickly. We're going to say y is equal to greater than 3x plus 2. Oh, darn it. I don't know why I wrote equals to. Y is greater than, oh, darn it. More. Y is greater than 3x plus 2. And then y is less than 3x plus 2. And take a look at what's the difference between what we wrote before and after, or right now, is that these have no equals. These are no equals. So that changes my graph in a very slight way, but it does matter. So if I draw my graph again, our slope is still 3. Our y-intercept is still 2. See, my characteristics, for the most part, have not changed, but a slight change of inequalities has. So 1, 2, put a dot. 1, 2, 3 over 1. 1, 2, 3 over 1, right? And we're going to draw a dotted line now. And make sure everyone knows this is dotted. Same thing over here. Oh, that's a terrible line. 1, 2, put a dot. Then we count on 1, 2, 3 over 1. That's my slope. And we're drawing a dotted line because we're not equal to it. So be careful that we're not equal to it. Now on the left here, let's take a look at this equation here. Y is greater than. Am I going to shade up or down? Now again, if you're stuck, take your pencil, put your pencil on your line and say y is greater, y is greater, y is greater. We're going to shade on top. Thank you. On the right side, y is less than, y is less than. Which way would you go, up or down? I would go y are less than. That means we're going to shade down. So super important. Make sure you guys can get those easy parts of this graph. And that's the only difference between our previous line graphs and our inequality lines, is that now we have to shade. So one cool thing is that if they give you these lines in slope-intercept form, these are super easy graphs to graph. Now we're going to work on one more skill today, and that's changing a graph that isn't in slope-intercept form into slope-intercept form. Now before we do that, I need to show one more warning. Here's a warning. We had a rule where if I say negative 3, x is, let's say, greater than 9. Okay, well, let's not use 9. Let's use 12, okay? If I want to solve for x, we have to divide the negative 3 out. Opposite of multiply negative 3 is divided by negative 3 to both sides. And if you remember, something happened to our inequality when I multiply across or divide across by a negative sign. Remember, this always works for multiplication and division, okay? And we have to flip the inequality. We flip our inequalities when we divide or multiply by a negative. As you can see here, I brought my bad habits with me, and I need to make sure I flip these values over. Super important that you remember this one skill that we talked about before, is that when I am when I'm dividing or multiplying across inequality by a negative sign, I have to flip my inequality. So we're going to practice that right now. We're going to do two of them, one with a flip and one without a flip. Let's do the one without a flip first. 2x plus 3y is equal to 12. And then I'm going to change this to inequality by changing that equal sign to a greater than sign. 2x plus 3y is greater than 12. So we've been working on this straight from week 1, opposite operations. If I'm solving for y, what numbers do I have to get rid of? I have to get rid of the 2x and the 3 in that order. Get rid of the 2x first and then get rid of the 3. We're going to subtract 2x to both sides, subtract 2x. Now, do we have to flip my inequality if I subtract to both sides? Nope, because remember, this rule only works with multiplication and division. So I subtracted 2x to both sides, no problem. Next rule, we want to get rid of the 3, and we're going to divide both sides by 3. I'm dividing by a positive 3. Oh, that's a positive 12. So this was a positive 12 here. That's why it's a positive 12 here. Y is greater than or equal to negative 2 over 3x plus 12. Oh, sorry, plus 4, because 12 divided by 3 is 4. Hey, awesome. Okay, easy peasy. All the skills we learned before about moving numbers around, changing a standard form equation to slope-intercept form, right here. Okay. On the right, we're going to do the same exact problem. I'm going to switch this around. The 2x minus 3y is greater than or equal to 12. So let's talk about the steps to solve this guy. I need to get rid of the 2x first, and then get rid of the negative 3. Opposite of plus 2x is minus 2x to both sides. Since 12 and 2x are not like terms, we write them next to each other, negative 2x plus 12. Let me ask you here, do we have to flip the inequality? Nope, because subtracting, adding, no special rule for that. Careful, I also kept the negative sign. We don't lose that. That's still a negative 3. Our next move is to divide both sides by negative 3. Divide both sides by negative 3. Negative 3. Negative 3. So negative 3 divided by negative 3 becomes a positive y. Negative and negative become a positive 2/3. And positive and negative become a negative 4. Now, along with this, we just divided across our inequality by a negative. That means we have to flip our inequality. We have to flip our inequality. And that's something we have to remind ourselves. And you guys will be practicing that in your iExcel. Okay. Now let's go ahead and take a look to make sure we are okay with this. Both these equations start off looking pretty nice. As we work through solving them, one of them called back a rule. If I divide by a negative, we have to flip our inequality, okay? Now let's go ahead and graph these both separately. On our left, on our right. My slope here is -2/3. My b value is 4. FYI, remember, do not write the x value. There is no x value for your slope. There's no x value. It's just the number in front of x. Y is equal to mx plus b. Leave the x alone. We're looking at the number in front. And that's where somebody has messed up on your test. So we graph the b first. 1, 2, 3, 4. We're going up here. Not 4 here. 4 in the y, because we call this our y-intercept, not our x-intercept. And our slope is -1, 2, and our run is 1, 2, 3. Oops, a little off. Let me erase that. And our slope goes like that. I want to double check if I made a mistake. Was this a solid or dotted line? Was this a solid or dotted line? To remind yourself, this is y is greater than or equal to. Equal to, that means we can be on that line. We're okay. That line is cool with me. And now, if you're not sure y is greater than the line, put your pencil on the line. Which way is y is greater? Thank you. Solid. And y is greater than, it means we're going to shade up. Okay? Because y is greater than. So we're going to shade all the parts on top. Make sure you even get the corner. Some people always forget that corner. But I think that looks a little bit messy, so I'm just going to draw a bunch of lines like this. Make sure you get the corner here. Some people always forget little corners. Okay, let's graph the run on the right. Our slope here is 2/3, and our y-intercept is -4. -1, 2, 3, 4. Put a dot. My slope is +2, 1, 2. My run is 3, 1, 2, 3. Put a dot. So again, my slope, rise over run, rise. To get to my next point, I rose 2 and I ran 3. Solid or dotted? This is less than or equal to. I'm going to draw a solid line. I'm a little off there. Now, my question to you, y is less than. Y is less than. Do we shade above or below here? Do we shade above or below? Y is less than. We're going to shade below. But if you're not sure, put your pencil, whatever you want, on this line. Y is less than. So we're going to go down. Okay, so we're shading below. Okay, that's the lesson for today. Hopefully you were able to keep up and it made sense.